Stars are big enough to sustain nuclear fusion for millions or indeed billions of years, before they too eventually run out of fuel. What happens next depends on the size of the star. Really big stars explode as supernovae after only a few million years. While the smallest stars burn slowly enough to be virtually immortal. Their expected lifespan is much longer than the present age of the universe, meaning that we've never seen one die. But for stars like the Sun, which have a lifespan measured in billions of years, astronomers have made many observations of what happens when the fuel supply runs out. They end with a whimper, not a bang. Here's how it goes, as revealed by Hubble observations of dozens of stars at different stages of evolution. First, the star swells up and cools down a little, becoming a so-called red giant. When the Sun does this, it will destroy the inner planets of the solar system. Next, the outer layers are puffed out, forming a dense cloud of gas and dust that totally obscures the visible light from the star. This stage, called a preplanetary or protoplanetary nebula, is tough to observe, as it's so faint. Only dim infrared emissions from the dust cloud and reflected starlight let astronomers see anything at all. It's also a very short period in stellar evolution, just a few thousand years long, so these objects are quite scarce. Hubble's images of preplanetary nebulae show a wide variety of shapes, hinting at complex dynamics going on inside. The spiral structure of this nebula is particularly unusual, and is likely due to a binary star system shaping the cloud of gas and dust. As the star ejects its outer layers to form the cold preplanetary nebula, the core of the star is left behind, leaving a small but very hot remnant. Over a period of a few thousand years, radiation from this hot leftover excites the gas in the preplanetary nebula, eventually making it light up like a fluorescent sign. At this point, the faint preplanetary nebula becomes a bright planetary nebula. In fact, these are bright enough that astronomers have long been able to see them, which explains their confusing name. Because they appear roughly spherical and have a greenish tinge when observed visually, astronomers using early telescopes found their appearance reminiscent of the planets of the solar system. Now, high-resolution observations from modern telescopes, including Hubble, show that their shapes are often far from spherical, and the planet-like appearance is pretty dubious, but the name has stuck. Eventually, planetary nebulae fade to nothing, as the gas and dust diffuse into space. All that remains is a tiny, dense and dim white dwarf, the ultimate destination of the Sun, billions of years from now. But for stars, there is life after death. The matter puffed into space by planetary nebulae forms the building blocks for new generations of stars and planets.